Hello everybody and welcome back. We're taking a look at the 2004 grade 7 level Gauss paper from the University of Waterloo. And we are all the way up to question 10, I see. So, question 10, the perimeter of the figure, and I guess they mean this one over here, in centimeters is, and we've got 30 and 28 and 25, 24 and 22. So let's take a look at this guy. He's got a whole bunch of right angles. That's fine. Let's see. So one thing I can say is this 3 centimeters is parallel to this 5 centimeters, which is parallel to this. And, oh geez, we've got right angles everywhere. And I notice I've got these 2 little hashed lines. And because they both have 2 lines going through them, that's sort of just a little bit of math code for these are the same length. Now, I don't know what that length is, but if I'm going to figure out the perimeter, I need to know all the lengths on the sides here. Okay, so what can we do? Well, let's redraw our figure and see what we can come up with. I'd like a straighter line than that if I can. There, that's a little better. So I know I've got a 3 up here, and I've got a 5 here, and a 6 here, and I've got right angles everywhere. In fact, I even have one here, but they haven't shown that to me, but if you want to, you can chase around the angles and see that for yourself. But they haven't given me that one, so I'm actually going to leave it off. Okay, and we're told that we've got the same length here. We'll use green. So this length is the same as this length. We could even give it a name X. Okay. So, I think there's a couple ways we might try and view this question. One way I could see is that the little rectangle sort of, let me see if I can find it. Sort of looks like, and this is a ratty piece of paper, but it sort of looks like we've taken a corner and almost folded it or cut the corner out in some way. Okay, that's almost what it looks like. Well, I admit that's a bit of a triangle, but that's the way I'm viewing it. Is it's sort of a little page that's got a corner cut out of it, not folded. I guess that was a bad example. But one way I can view this is I could say, well, let's actually just sort of complete our rectangle here. Okay, what would it take to complete this rectangle? This is one way to view the problem. It's not the only way. I'll go through another way in a moment. But if I wanted to make a full rectangle, I'd have to add in a little rectangle, the rectangle corner that was sort of cut out. But it's not just a rectangle, it's a square. Okay. Now, what I lose in perimeter, I've lost this guy. He's not on my perimeter anymore, nor is this X. But I've gained a perimeter. 2 X's. Okay. So I got my 3 here, and a 6 here, and a 5 here. So I've gained a little bit on my perimeter. Or, not gained a little bit. I've gained a square, so I've gained a little bit of my area, but my perimeter is the same. Okay? So, this perimeter, same perimeter, but this perimeter on the bottom, why, it's a rectangle. It's a rectangle with side 5 and side 6, and there's a formula for the perimeter. Take the 2 sides, add them up, multiply by 2. We get 2 times 11, and that'll be 22 centimeters. Okay? Because what we've lost is 1 X, but we've gained an X. And what we've lost is another X and gained another X. Okay, so these X's sort of cancel each other out. There's no change to the perimeter. And that's one way to view the problem. It's not the only way. Let's redraw our picture. Some of you might have done it this way. Okay, so we've got our X's here. It's the same length So one thing I can think of is, rectangles, sure. One thing we could do is we could break this down into some smaller rectangles. Okay, so we had a 3 up here. So if we had a tiny littler rectangle, maybe we'll make it the orange rectangle. It's got 3x, so opposite this 3 should be another 3, and over here should be x. Okay. So then what's left over? Well, if this little bit is x, we must have 4 minus x for this length. And now we have another rectangle. A rectangle whose sides are 5 and 4 minus x. Okay? But notice here, we have a side, we should be able to say this side here is a length of 5, but it's also a length of 3 plus x, so we can notice that 3 plus x is equal to 5. From there, it's really quick to see x is 2. And once I know x is 2, suddenly I know that we've got a 2 here, and a 2 here, and a 2 here, and this that should be a 6 minus x, not a 4 minus x. I was jumping ahead. I was filling it in with my head. So that should be 6 minus x. This guy over here should be a 6 minus x. Sometimes this happens. Your head sort of does a calculation faster than you. I wasn't actually aware that this is 2, because I knew it didn't really matter because of this perimeter method. But apparently in my head, I'd already worked out that it's a 2 and subtracted the 2 from 6 to get that 4. At least that's my current working theory. But now this 6 minus x is 6 minus 2, so I can replace it with a 4 and a 4. So now I've got a figure, and I know all the sides, 4, 2, 2, 3, 6, 5, and I can add those up. 3 plus 2 plus 2 plus 4 plus 6 plus 5, and we get the 4 and the 6, that's 10, the 5, the 3, and the 2, that's another 10, so we're at 20, and the final 2 up there, 22 centimeters. So no matter which way we slice it, we're getting 22, which is E. Okay. So that does it for the questions in Part A. We're going to move on to Part B, and that'll be in our next video when we take a look at question number 11. So thank you for watching, and I will see you guys next time.